Hi mathematicians, I'm going to go ahead and do some problems from section 2.1, and let's go ahead and start with number 1. And so number 1 says, suppose S of t is the position of an object moving along a line at time t greater than or equal to 0, right? So we're only dealing with our right side of our graph, right? We only care about this part, right? For t greater than or equal to 0. What is the average velocity? It says what is the average velocity between the times t equal a and t equal b. All right, and so I chose to do this one because I feel like it might seem a little strange because you're not going to get like a number answer. What they want you to do is we're going to write the equation for average velocity, and it's the s of t1 minus the s of t naught over t1 minus t naught. And so here our t1 is a and our t2 is b. So we're going to go ahead and go s of a minus s of b over a minus b. And that is our average velocity. That is the answer. Okay, let's move on and let's do another one. Let's go ahead and I'm going to do number 3 here. And so it says the function s of t represents the position. Represents position, right? Of course, because we keep doing change in position over change in time, right? So s of t represents the position of an object. This whole thing is just really about average velocity of an object at time t moving along a line. Suppose s of 2 equals 136 and s of 3 equals 156. It wants us to find the average velocity of the object over 2, 3. Okay, so again, I'm going to go ahead and write my equation. S of t1 minus s of t naught over t1 minus t naught, right? This is the equation for slope, right? This is your equals y2 minus y1 over x2 minus x1, right? I just want to point that out. We are just doing slope here. But in this situation, it's not a straight line, right? Over here, this was always for our straight line, right? Our y equals mx plus b line right there, okay? All right, so s of t1, so we're going to need our s of 2 minus our s of 3 over 2 minus 3. Okay, and so what is that? Our s of 2 is 136 minus 156 over 2 minus 3. And some of you might be complaining, you know, that you want these switched, right? Maybe you want me to write this instead. If that makes you more comfortable, that's fine. But in the end, it won't matter. In the end, we'll get we'll get the same answer here. So 136 minus 156, that is going to be minus 20. 2 minus 3 is going to be minus 1. You're going to get V average equals 20. Okay, just to show you that it would be the same thing if we had gone the other way. We would have gotten 156 minus 136 over 3 minus 2. And so we would have gotten 20 over 1. Okay, so there we go. V average equals 20. Make it nice and visible. For my teacher to find. Okay, let's go ahead and do another one. Let me find something that maybe looks a little bit more difficult. And let's do number 19 here. There we go. All right, number 19 says instantaneous velocity. And so it says consider S of t equals negative 16t squared plus 100t. And then it wants us to complete the following table with the appropriate average velocities. Then make a conjecture about the value of the instantaneous velocity at t equals 3. Okay, so they gave us this table, and so it says 2, 3, and then 2.9 and 3, and then 2.99 and 3, 2.999 and 3, and then 2.9999 and 3. I love it. Okay. And so here we're going to do the average velocity. And so we are interested in actually the instantaneous velocity at time equals 3. Okay, so we have this function here. If I were to graph this, we would get some kind of upside down parabola, right? I know that because we have this negative out here. Okay, and so we're interested in the absolute or the actual instantaneous velocity at time equals 3. But we don't know how to do that yet. Okay, that's why we're in Calc 1. So instead what we're going to do is we're going to take the average velocity and we're going to make that interval that we're taking the average velocity over smaller and smaller, right? Here the interval size is 1. Here the interval size is 0.1. Here the interval size is 0.01. And so this denominator, right, so we have V average equals S of T1 minus S of T naught over T1 minus T naught. This interval here is getting smaller and smaller. right? And so what we're going to eventually do is we're going to look at what is this value, what is this V average when this gets infinitely small. And when we get infinitely small, we're actually approaching zero, right? That's what happens. We want to look at, when we want the instantaneous velocity, we are going to look at the average velocity as this distance approaches zero. Okay, and this whole idea of looking at the behavior of something as we approach a value, that's when we start talking about limits, right? How does this look as we approach this value? Okay, and so we're asking for instantaneous velocity. We're asking, how does this look as this approaches zero? Okay, but for right now, we're still doing average velocity. And so what we're going to do here is I'm going to label this A, B, C, D, and E. And so for A, we're going to go ahead and A V average equals S of T1 minus S of T naught over T1 minus T naught. So in this situation, we have the S of 2 minus the S of 3 over, let me change those, S of 3, S of 2, I'll try to be consistent, over 3 minus 2. And so that becomes, what I'm going to do now, is I'm going to plug this in to our function up here, right? So we have our function S of t equals negative, I'm going to write that down here so that we have it, equals negative 16t squared plus 100t. And so I'm going to go ahead and plug these values in there. So I get negative 16 times 3 squared plus 100 times 3. That is my S of 3 minus negative 16 2 squared plus 100 times 2 all over 3 minus 2. Okay, what's that going to be? Negative 16 times 9 plus 300 minus negative 16 times 4 plus 200. All over 1. 16 times 9, I know that 9 times 10 is 90. I know that 6 times 9 is 54, so this is going to be negative 144 plus 300 minus 16 times 4 is going to be 40 plus 24, negative 64 plus 200. I don't know what that is. And so what do I get here? Negative 144 plus 300. That is 156. Negative 64 plus 200 is going to be 146. Is that true? 136. Is that true? Yep. 136. So we have 156 minus 136 equals 20. Oh, and you didn't get to see any of that. Sorry, I was talking and... Okay, so the average velocity up here, let's see if I can just get more of this deeper in, is 20. Okay, and so then you're going to have to do the same thing with B. I'll do B over here. V average is going to be S of 3 minus S of 2.9 over 3 minus 2.9. Okay, now I know S of 3. That hasn't changed. And so S of 3 was 156. So I get to write 156 over here. And then S of 2.9 minus negative 16 times 2.9 squared plus 100 times 2.9. Okay, I'm going to have to get out a calculator for all this. And then over top of it, you're going to do 3 minus 2.9. Okay, I'm not going to torture you with my math crunching here, but you're going to do that, and you're going to write that value here. You're going to do the same thing, okay, and this interval is going to get smaller and smaller, and you're going to get closer and closer to the instantaneous velocity at time equals to 3. Okay, so that's what's going on with problem number 19. And so this was 2.1. And so hopefully me doing those problems was helpful. If you want me to do any others from your homework, please reach out.